What's going on, everyone? My name is Johnny Bannon, and I will be your instructor for this video series. So this is going to be the last video we do going over trunking. This is going to be our little bit more complex lab, where we're going to do some trunk pruning, uh, configure trunks dynamically, do some Wireshark captures, look at the differences between static and dynamically formed trunks, and then we're also going to change the native VLAN on a trunk, look at the error we get, just so I can show you guys. Now, it's not in the instructions here for the guys in our paid course, or for even you in the free course. The GitLab will have updated instructions, okay? So we're going to start off with step one. And again, we're into my EVE-NG environment. So step one, turn on all devices. Come over here to more actions, start all nodes. And then number two says paste baseline from Git. I'm leaving that in there for the students in our free course. If they want to use the baseline, they can. But going forward, all the labs for anyone in our paid course, the baseline's already going to be on the switches when they start up. And any technology that we're not learning, it's already going to be configured. So what we mean by that is, since this is a trunking lab, I'm not going to have you configure and assign VLANs. No need, right? You've already done that 3 times in the past lab, so the VLANs are already made created and assigned right when you turn on the lab environment. We can see that if you come over here to startup configs. This will actually show you the startup configs that are going to be applied to that switch, okay? All right. So now let's verify if VLANs are created and assigned properly. So moving on to step 3, we're going to console into all 3 of our switches here. So switch 1, we're just going to verify that the VLANs are created because we don't have any computers or endpoints attached to it. Switch 2, we're going to make sure that the VLANs are created and assigned properly. So VLAN 10, our sales VLAN, needs to be 01. VLAN 20, the engineering VLAN 00. Awesome. Switch 3, we're going to do the same thing. And let me get our gears here. T set up nicely. Okay. Same thing, show VLAN brief. So our sales VLAN is in ETH00, engineering VLAN in 02. Awesome. So our VLANs are created and we verified them that they're in the correct ports. Now let's do some reachability tests. So I'm going to come here to PC7, console in. I'm going to console into PC6. And let's see if PC7 can ping PC6. Obviously not, we don't have a layer 3 gateway. But let's see if it can ping the other computer. No, it cannot. And why is that? Because we have not formed our trunks yet. So now let's go ahead and create our trunks. So step 5, create static trunk from switch 2 to switch 3. Let's go ahead and do that. So let's just look at what we got here with you show interface description. Okay, so we know our trunk has to be 02 and 03. And the reason I'm not just automatically going, okay, 03 is because sometimes you're not, 98% of the time you're not at the actual location you're troubleshooting. So we got to get used to navigating the CLI without a diagram right in front of us. You should have network diagrams built in your enterprise, but in my videos, I just like to show you how to kind of navigate it if you're going in blind, right? So I could do show CDP neighbors, and I can see that switch 3 is connected on ETH03. So from switch 2 to switch 3, I need a static trunk, and I'm going to turn off DTP messages. So let's do this. The command is going to be interface 03, switch port trunk encapsulation .1q, switch port mode trunk. Okay, now you may be wondering, well, it's a static trunk, so shouldn't the dynamic trunking protocol already be off? Well, let's see. how do we check to see if it is? We have this command right here, show interfaces ETH0/3 with switch port at the end. And even though we created a static trunk, we see that we configured a static trunk. Our mode is trunk. Our operational mode is trunk. We set up .1q. Look what's still on. The negotiation of trunking is still on, which means the DTP messages are being sent. So even if I do a capture here, let's see if those DTP messages are actually being sent. So these are spanning tree messages. We're gonna have to wait for like a CDP message to come across. And boom, look at that. Pause this. The dynamic trunking protocol, DTP, is still coming across. And that is it's just crazy, right? Because we made a static trunk. So, I mean, what the heck, right? And we see it's coming from both sides here. If we really want to make sure, we'd have to look at like what our MAC address is, but it's coming across, even though we have static trunking on. Let's get out of that, back into secure CRT, and let's turn those DTP messages off. So how do we do that? With the command switch port no negotiate. Now if we go look again, boom, negotiation of trunking is done. It's out of there, right? So let's go do that on switch 3. Interface ETH03, switch port trunk, encapsulation.1q, switch remote trunk. Real quick, right? Because we've done this a few times. And then switch port no negotiate. And now let's go ahead and start a capture here again. And we'll come back and look at that after we go move on a little bit in our steps, okay? So step 6, create a dynamic trunk from switch 2 to switch 1. So switch 2 to switch 1. And one thing I forgot to do here, guys, is I'm going to make a description. This is going to be trunk to switch 3. Awesome. So now, step 6, create a dynamic trunk from switch 2 to switch 1. We want switch 2 to perform active negotiation. And we want switch 1 to only receive negotiation messages. So that means we need to put switch 2's interface going to switch 1 into dynamic desirable mode. So that's going to be interface ETH02. So interface ETH02, description, trunk to switch 1. What we're going to do here is do switch port trunk encapsulation.1q, and then switch port mode dynamic desirable. Okay, let's go to switch 1 and do the same thing. So we're going to do our neighbors command as well. K02 is our connection. So interface ETH02, description, trunk to switch 2, switch port trunk encapsulation.1q, then switch port mode dynamic auto. So we're going to be just receiving the DTP messages. And before we move on, let's see if we formed a trunk. And boom, we did. So you can see here that the mode is auto instead of what we typically see with on. Like switch 2, if we do that command, show interface trunk. Look at that. Our mode's desirable here and on here. Pretty cool, right? We actually see these trunks forming in different ways. Now step 7. Let's go switch 1 to switch 3. Let's have both sides actively negotiating. And here we're going to try actually not setting our encapsulation and see which one these switches choose, ISL or 802.1q. So let's see how we're connected to switch 3 from switch 1. It's going to be ETH01. So interface ETH01, description, trunk to switch 3. We're just going to type in here switch port mode, dynamic desirable. And we're going to go to switch 3. Let's do the same thing, neighbor command. Okay, it didn't come up our neighbors. I don't know why. Again, sometimes these emulated switches, things just happen like that. So we see we're connected on 0, 1 though, from switch 3 to switch 1. We're going to go internet interface, ETH01, description, trunk, switch 1. I need my slashes. It's the OCD thing. And then we're just going to type in switch port mode, dynamic, desirable. Awesome. And now let's test to make sure our trunks have formed. And look at this. Isn't this crazy? So these Cisco switches in our lab environment, this iOS version, decided that when everything's left up to itself, its own negotiation and encapsulation and trunking, it's going to pick ISL. So what does this say? That we should probably always choose our encapsulation because we don't want to use ISL. No one uses it. It's not the standard, really. The IEEE 802.1q is a standard. So let's go ahead and finish up this lab. So now we're going to ensure all trunks only allow active VLANs in the lab environment. So what this means is we have VLANs 1, 10, and 20 that are active in our environment. We're going to go ahead and make sure that that they only allow 1, 10, and 20 across the trunks. So I'm going to go ahead and do this. On switch 1 first, we're going to do interface range ETH02 to 01 to 02. You can see that here. And what I'm going to do is this command here, switch port trunk allowed VLAN 1 and 10. Now you may be saying, well, hey, Johnny, I mean, what about VLAN 20? And I'd say, oh, shoot, you're right. Let me go add that real quick. Ooh, crisis averted, right? Well, let's just go verify, because we're good network administrators, that we're allowing 1, 10, and 20. And look at this. We only have VLAN 20. Well, what happened? Well, in this command right here, switchboard trunk allowed VLAN command, it doesn't add it. What it does is it overwrites. So if I do this, now all are allowed. And if I want to add just one more, I can just do this again, or I can use this keyword add. And that'll also add on to that trunk pruning. Okay, now let's go ahead and interface range ETH00 through 1 over here on switch 2. Switch port trunk allowed. We're just finishing up that step by only allowing VLANs that are active in our enterprise to come across switches. Let's see, do show interface trunk. So we're going to do interface range ETH01, comma ETH03. And switch port trunk allowed VLAN 1, 10, and 20. As you can see here, with this range command, if it's not like 1 through 2, like on switch 3, it's 0, 1, and 0, 3, you can kind of do a comma and still be allowed to configure both at the same time. Okay, now let's go over our last step. Verify trunks, record how they were formed. We kind of already been doing this, right, throughout the lecture. But like on switch 3, if we type in show interface trunk, we can see that this was formed with dynamically, and it decided to pick ISL because we didn't tell it exactly what encapsulation to use. And then this one's a static trunk, right? And we told it to use 802.1q on this interface. Okay, so now we're performing that Wireshark capture on our static trunk, and we're also going to do one on our dynamic trunk, and just look at the differences. So if you look at this now, there is no DTP messages coming across, okay? And we don't see any trunking messages coming across because we don't have to, right? In our dynamic trunks that we formed, we're going to see DTP messages come across. But in this one, it's just Yeah, nothing. I mean, we saw this dynamic trucking protocol earlier, but now once both were set to static and had their negotiation turned off on both sides from switch 2 to switch 3, we got nothing for DTP. So now I'm going to perform a capture from switch 3 to switch 1 on ETH01. And remember, this is where we did completely dynamic. We let the switch choose its own encapsulation and its own trunking mode. What I'm going to go ahead and do here is just shut down that interface. I want to see that trunk be formed, and then no shut. Cool. I think this should be enough. Oh, just coming at you like fireworks. So we can see here, trying to find that DTP message that started it. We may not find it. Here we go. So we can see here we have our DTP message here. That's going to say ISL has been negotiated. And it's so weird because it still has that 802.1 queue, but we see this ISL frame here, which doesn't, But again, that's why I like to look at it. Even though it says it formed an ISL trunk, we can still see 802.1 queue come across in those messages. So maybe, this might just be an even G thing, but we can see that ISL was negotiated, but anyways. So kind of weird, but it looks like in the real world, and we're going to have a whole video on using real world switches and real world routers just to kind of compare what I call the even G isms. But pretty cool. We get to see what's actually happening on the wire. And that's going to be it for this trunking lab video. I want to thank you all for viewing and stay tuned for our next videos when we go over CDP and Ether channel. Thank you.